Awesome. We're here. Giovanni, we've been talking for the last couple of days, weeks, months about AI. How can we help companies? What can we do? What's work? What's hype? What's not? We set up to record this morning, and then today you wanted to change things,
Yeah.
which which is fun and funny because now I want to set up like we want to talk about garbage in, garbage out. It's a concept that universally I think people know what it means. Like if you ingest something that's not good, you cannot expect a good result. Now we understand what that means, but to set some foundation, like from a data science, from an AI perspective, you had a really good definition and explanation that I really want to surface and bring to light. So can you share what does garbage in, garbage out as a concept mean? And how does that impact the new ideas that you were just telling me about?
Yeah. Well, when we think about garbage in, garbage out, there's a trivial form of garbage in data, which is different formats in dates or some typos, some data that might be actually biased or incorrect. But then I was actually thinking about experiencing this problem when I transitioned from my career as a researcher in physics into data science, which was basically 10 years ago. And it's kind of interesting to examine the story because I think what actually happened is that people tend to think the algorithm is the added value to the business. But really, if you examine like how this is evolving and also some basic principle in statistics, what you will find is that the data has always been the central value because the algorithms are available to everyone. So let me explain that a little bit better. So when I was working in physics research, basically our job was to solve some crazy math that nobody can solve on paper numerically through algorithms, through computation. For example, uh, like 20 years ago during my PhD thesis, I solved a thing called a Sommerfeld integral. Well, what that is basically an integral that allows you to calculate how light propagates and at the nanoscale. But this is not the point. The point is that my job was to create an algorithm, and the algorithm was the crown diamond in my job because maybe at that time there were only a couple of other people in the world who could solve the same Sommerfeld integral. And so basically, the algorithm was the thing that allows you to have an advantage over other people in creating new knowledge that you can publish in academic papers. And so what happened is that like when I switched to data science, I had this, my first assignment was actually during the job interview. Like there was a phase in which you had to basically make a case study and present it in front of the data team of the company. So what I was thinking at the beginning was probably they want me because of my math skills. So I have to design like a secret algorithm that nobody has. And then when I started working on the assignment, I realized one thing that was initially crazy to me. That was like all the algorithm, and this was 10 years ago in 2016. So you already had spectacular machine learning algorithms. Like the main one was called gradient boosting. And this was spectacularly good at extracting any complex pattern from data already. So you didn't like if you just had some data and you plug them into the algorithm, it would already like in a couple of minutes, it will tell you like what the pattern was between whatever variables you had into your data set and what you wanted to predict. So like I was wondering, so in this case, I had this assignment in which I had this classical machine learning assessment data set, which is called the MNIST data set, which is basically handwritten digits. And you want the algorithm. So it's all the digits from 0 to 9, and they're just images of handwritten numbers, basically. and you want the algorithm to classify them correctly. So if I just have an image of somebody drawing a 0 or a 5, the algorithm has to has to predict the correct label. And so what I did was basically taking all the data, since I had all the algorithm in the world, open source, I just stacked them and trained many, many different models with the same data, and then taking a new sample and trying to predict what it was by stacking the prediction from many algorithms. So eventually, like, you will have a stack of algorithms that were voting. So you presented them like a weird 0, and they had to vote. Maybe like 8 of them said it was a 0, and 2 of them said it was a 6, and eventually it said 0 because like 8 of them. So what happened was that even if I stacked as many algorithms as I wanted, what I would find is that there was a segment of the data set, which I called the ugly numbers, that basically not only were very hard to predict, even if you took many, many algorithms that make them vote, but if you actually took this segment only and you trained data and you trained a model with this segment only, you will get garbage in, garbage out. Because this segment was made out of handwritten numbers with a really, really bad handwriting, where you had a 0 that looked like a 6, or an 8 that looked like a 0, or a 0 that looked like an 8 with something in the middle. So eventually, the moral of the story is that you would not improve the accuracy by using more models or using a better model. The way that you actually increase the accuracy was by cleaning up the data.
So it sounds like,
yeah,
it sounds like you don't just need newer algorithms, right? If the 0 is written ambiguously, it could look like an 8, it could potentially look like a 6, maybe even a 9. Or even you take a 6 and you put that upside down, that's a 9. So you can even have issues where you got to tell it, hey, this is the direction you need to read it, because a 6 and a 9 are pretty much the same, but inverted. So any algorithm won't solve the problem. It's the data that has to be properly displayed, properly structured. But then I think what we were talking about earlier as well is that context piece, so that the algorithm knows what to do with the data that it is ingesting, and then produce the output that is most relevant. Am I getting that correctly, or where am
yeah,
I going
that's
wrong?
right. In fact, basically what you need to do and what you just described is called feature engineering.
You got prompt engineer, you told me about context engineer, now we got feature. We're gonna engineer everything. Let's go. What's that? Tell me, like, in your words, and how does this apply to like AI in business? What is the difference between just a feature list and feature engineering in the way that you understand it?
So exactly like you said, you can have an image of a 6 or a 9. And then if you had an extra column, let's say, that says uh, it has to be read this way. So if it's up, it's a 6. And if it's down, it's a 9. That will be a feature that you add to the model.
So it's just additional instructions, if I understand that correctly?
Feature engineering. So AI can, I was talking about gradient boosting, which is a very old machine learning model. But in more modern AI, like deep learning and convolutional neural network, the AI itself automatically creates the features. But what features means is something that we can understand intuitively, because it's basically like, for example, when you recognize something in vision, for example, when you recognize an object, there are certain features that help you recognize it. So feature engineering is basically trying to persists a methodology for the AI to look out for those features.
How is that different from context engineering?
I think context engineering is basically an evolution of feature engineering, but we're in a completely different realm because right now I was just talking about traditional old, let's say, classical machine learning models and deep learning. And context engineering is more related to the more modern AI, which is based on large language models.
Okay, so let's explore this new, how do I say, let's call it evolution, called context engineering. How does that, what's in your experience or in how you've seen data being applied in business? How does context engineering help a business either make better decisions or avoid mistakes?
The thing is that machine learning and nowadays AI have the same problem, that they work, let's say, perfectly at a mathematical level, but a mathematical possibility is not always good for business.
What does that mean? What does that look like in the real world?
So I was telling you this example about, imagine that you want an AI that is trying to predict if it's raining or not in a certain location. And it's got data from that location and all kinds of information. And eventually the AI, it's mathematically plausible that the AI is just, looking at the number of people with umbrellas in the streets and telling you if there's a lot of people in the streets with umbrella, then it's raining. So that is a completely acceptable mathematical conclusion. But at a practical level, it serves absolutely no purpose because it's telling you something obvious. But in general, I think the first generation of AI applied, they saw that the models got a lot smarter. And so the first thought for the first generation, which I've read recently some articles that said that has failed 95% of the time in every implementation um, um, attempt, is that basically you feed a lot of context into the AI and let the AI work out how to do things, basically giving it a lot of information because recent models have a huge context window. So they can basically analyze a lot of information together and not forget about it. So eventually, like at the beginning, they just thought that the only problem was memory. But even with a really good memory, AI can make a lot of mistakes because of what I'm saying. And this is why you constantly have hallucination. Because what AI is doing is basically assigning a probability to try to match the content that you feed to the AI to something else. So for example, like when you ask a question, he has the whole dictionary about the topic, and he has to choose like what's the next word, and he has to construct sentences that way. But each word that he decides to put in place in the answer has a certain probability score. So the AI is a probability machine. And if you increase the possibilities, you increase the probabilities also of things that are not related to what you specifically want to happen. The way that we have been trying to solve this in the first generation of AI is through prompt engineering, which basically boils down to trying to describe as exactly as possible the task that the AI has to do. So the main problem here is this. In reality, you have many possibilities of which you as a human are not aware of because you have a very specific context. And it's impossible to communicate with prompt engineering your specific scope in words if you have a huge amount of information. And this is just because you're creating many mathematical possibilities when you increase the number of information that you feed to the AI. So in what happens in context engineering is that you're not just trying to describe. So when prompt engineering works, it's because actually you're not sharing that much information. You're like narrowing down a little bit information, and then you're trying to specify the task in the clearest and most strict way, in the strictest way that you can, and then it works. But if you increase information, at some point the AI will start to hallucinate more and more and more and more as you increase the information. Even though, even if you're within the window, the context window that it can memorize. So what you actually need to do is to embed the scope that you're interested in into the infrastructure which the AI is navigating. And that is
Yeah.
much more effective. Not only because you don't have to repeat things 10,000 times. That is like also something advantageous, but it's just the only way to make it actually work. That every time, so when you say revenue, you have to embed into the revenue data how you calculate the revenue, when it's valid, if it's the same formula used for market. Apart from not having to repeat that every time that you prompt the AI, it would actually make the automation of AI as an executive co-pilot work, because otherwise you will get just a huge chance for hallucinations.
Discrepancies, hallucination. I think a really easy example of that is if you look at revenue, right? A common question: how much was my revenue how much revenue did I generate in the last 3 months? The CEO might have one idea of what revenue means or one definition, but the sales team might have another, marketing might have another. So depending on each person or department's definition, you'll have a different answer. In the case of marketing, they may count revenue as once the sale of the product has been made, once you check out, let's say if it's an online purchase. But maybe the sales team, for them, revenue is once the money is received into the account or whatever, right? Because there's a delay between checkout and once the money is received. So embedding all that context and setting those definitions at the infrastructure layer can allow a team to receive the information they need, knowing that everyone else has the same definition of revenue in this case.
Exactly. And so basically it's all about having new data structures in which, I think there's two parts. One is centralizing the business scope, and Palantir calls this the ontology. So the ontology are like the rules by which the AI has to work.
And those, yeah, go ahead.
Yeah, it's like a general contract between you and the AI.
And okay, so let's take it this in a different direction or the opposite way. We're seeing like a lot of companies want to implement AI, and a lot of them want to do it quickly. And I think you mentioned this stat earlier: 95% of AI implementations fail. Do you think? Well, I can tell you what I think. I think that there's a large part of the failure rates due to the lack of time being spent on the infrastructure, on the context layer. Going back to the garbage in, garbage out, right? If you're not taking the time to build a proper foundation, you can't expect the house to hold for a long period of time, or you can't expect the house to hold during a storm or when you're doing different stress tests. And I think that's I think there's a lot of hype around AI, which maybe pressured certain leaders to make decisions to implement AI without taking the proper amount of time to get the infrastructure layer set up in a way that works for their context. But I think that given that people have been either burnt or hurt or whatever, we know that AI as a technology can help and bring benefits. It's just a matter of how do we do it right and how do we do it in a manner that is relevant for the context of my company, of the next company, of the next company.
And the answer is doing it right. So you don't necessarily, so the problem that I see is not that you want to have like this AI transformation really fast. This is not the problem. The problem is that you're doing it wrong. And if you do it wrong, it can do more harm than it could do good.
What does wrong look like? How have you, yeah,
The,
how do you know you're doing
the,
it wrong?
if you're so basically doing it wrong means what I just explained before, feeding too much, giving too much information to the AI and hoping that the AI figures this on its own. So it's like taking a genius that lived his life in a library, his entire life into a library, and is the most intelligent person in the world, and has zero context about your business and your scope and your objectives, and putting this person, giving all the documentation that you have about your company to this genius and expecting the genius to figure out what's the next move. I mean, the genius can come up with a lot of intelligent answers that are not really good for your company, basically, at an operational level. So what you want to do is to create the infrastructure that guides this genius intelligence into precise final actions that you want to achieve.
It's funny because as you talk, because two things came to mind was, people, and there's nothing wrong with that, but people uploading all their company, let's say policies, company handbooks, things like that, into Claude or ChatGPT, and then like, okay, build me the strategy for the next 6 months, and it's like, cool, you've got a really confident sounding strategy. It's going to sound like your brand. It understands maybe the context of the past, but I don't think it understands the context of the future, where you're trying to go, and how does that, and where is the real world today, and how does your business, when it comes into contact with the real world of today, that part is missing. And I feel like, as humans, we know when I'm talking to you, I understand there's a certain level of context that I really have in my mind. So I don't need to say like, okay, act like Giovanni. Then I say my question and then you answer. And then, you don't do the same for me, because humans instinctively can switch, right? If you're talking to your doctor versus your lawyer, you can switch context. But for AI, that needs to be defined and clearly too. How do you like enable enough room for AI to be able to give you answers you maybe didn't think of, but not necessarily going too far out and hallucinating? Or maybe there is no way, and that's where the judgment layer, the judgment that humans have, that's where we come in. What are your thoughts on that?
So first, I wanted to say something important about what you mentioned before. That is that if you feed all the data from your company or even the code, which is what ends up ending when companies don't create a context layer, is that you're exposing your company to a massive security breach. Because basically
How?
this happened to Disney. So they were trying to implement this AI transformation roadmap, and it was based on the old way, which I just said, dumping information into AI, and the AI was hallucinating, and so the employees were manually trying to use like ChatGPT and other tools to break down some parts, and eventually they ended up sharing some information that became public, some Slack information, I think. And I think eventually Disney prohibited the use of Slack altogether in the company because of this breach. To be honest, I can't remember the whole story exactly. I can look it up. But the thing is, first off, is that it's not going to work and you're going to end up using ChatGPT probably. And then the other thing that I wanted to mention is that the AI doesn't distinguish between stale information and fresh information as intuitively as humans who know their business do.
Wait, hold on. So you're saying, let's say I have a revenue report from 3 years ago and I feed that into AI and then I have my revenue report of like 3 days ago, AI is going to weigh those two reports equally when me as a human, I can understand that I know what the context was 3 years ago and why the revenue was that way versus, and I can understand the context of 3 days ago and why the revenue is that way. But AI doesn't know that maybe 3 years ago we were in a different context than 3 days ago.
Yes, yes. And in fact, like the solution would be that you would specify that in the prompt. And the thing is that this is not scalable. The only way it is scalable and you can get agentic AI and not just a chatbot is that you embed all of this context into the data. And so you create some metadata that explain all of this. And so that way you don't have to, I mean, it's humanly impossible eventually, if you think about it, to inject all the context that the AI needs all of the time. This is human impossible. And you can see that how impossible it is when you try to scale AI. Because like if you are just chatting about one single problem with ChatGPT, probably, you make you make the best effort you can make with your memory in your brain to try and convey all the context that you need to convey for the foundation model of the AI to actually have a lucid snapshot of the reality that you're trying to interpret through it. But this is not going to scale if you on an enterprise level or a big organization in which you want to have independent agents, as you say, looking at the data and sending you an alert and saying, oh, look, since the cost of gas increased, you need to optimize this logistic route starting from next Monday. So if you want to arrive at this level of AI, which you basically have automatic business intelligence agents that tell you things that you don't even need. You want the AI to be proactive and tell you things you don't know. The only way this is going to work is if you embed the context into the data. And so that you can, so it's got two levels. One is embedding the context into the data as metadata. And the other level is that you create some guardrails and you displace the authority to execute actions through a system that works with precise instructions and that can evaluate if there's enough, if the decision made by the agent is, let's say, complies with a standard protocol, security protocol. And if it doesn't, it puts a human in the loop. And so if you think about it, this switches totally also the role of the human workforce. Because the role of the human workforce, instead of manually doing some manual job that could be automated by AI, becomes governing the data, the system that decides what are the standard protocol actions that are totally acceptable and what need reviewing, and basically contributing to so they must own some data, own some processes, and contribute to the context layer. This is the new role of the workforce, I think.
Of the knowledge workers is judgment
And then, of
contribution.
course, taking actions based on the insights that the AI delivers.